let's talk about graphing ellipses. We are going to start with our formula here, x minus h squared plus y minus k squared. This is over a squared, this is over b squared, and it's equal to 1. So you might have seen two different versions for the equation. We could easily switch this to be the b squared, this could be a squared, but for an ellipse, a is always greater than b. So whichever one is the big number is the a. All right, let's start with a sample equation. We're going to use x minus 3 over 4 plus y minus y plus 1 squared over 16 is equal to 1. So first let me put up a coordinate plane so we have something to graph on. Y-axis, and let's get my x-axis going. There we go. All right, so first let's identify the center. The center is the opposite number that's in with the x, so that's going to be 3. And negative 1 is the opposite number in with the y. So I'm going to go over 3, 1, 2, 3, and down 1. And right here is my center. Now let's take a look at the number underneath the x, the 4. So the square root of that is the radius in the x direction. So if it's 4, then the x radius is going to be 2. So I'm going to go over 2. There, 1, 2, more over there. There. And then the number underneath the y, at 16, the square root of that is going to be our axis in the y direction. So the square root of 16 is 4, so we go up 1, 2, 3, 4. So do that yucky line. Okay, there we go. And down 4, 1, 2, 3, 4, there. And then connect the dots, and we have actually already finished drawing our ellipse. So here we go. So my ellipse looks like this. All right, now let's identify all the important points on the ellipse. So first, up here and down here are the vertices. The vertices are always on the longer axis or the major axis. It's just the tall one. So let's start with our center, which is at 3, negative 1, and we went up and down 4. So the vertices are going to be at 3, negative 1 plus 4 is 3, and negative 1 minus 4 is negative 5. So those are the vertices. The points going the short way are called the covertices. Those are on the minor axis. So we started at 3 and we add and subtract 2 to it. So my covertices are at 1, negative 1. And the other one will be at, oh, did I just mess that up? Let's see, the covertices are at, 1, negative 1. And 5, negative 1. There we go. Okay, so I briefly mentioned the major and minor axis, so let's just write that down formally. The major axis is the long direction. It's 2 times the longer radius, so 2 times 4 is 8. The minor axis is the short direction, so 2 times 2 is 4. And the last thing that we have to worry about are the foci for an ellipse. The foci go somewhere inside the ellipse along the major axis, and they're calculated using the equation a squared minus b squared equals c squared. The c is the distance from the center to the foci. So let's see, I've got 16 take away 4. That's going to be 12. So c is the square root of 12, or 2 root 3. So I need to take that value, 2 root 3, and add it to the y coordinate of my center. The center, remember, was at 3, negative 1. So I'm going to take 3, -1, and then I'm going to add and subtract 2√3 to that number. And those are the foci. So I've identified the graph of my ellipse, the center, the vertices, the covertices, the major and minor axis, the foci,